Okay, so good afternoon, everyone. I hope you all enjoy the lunch. First of all, thank you very much. It's an honor for me personally and also SESNA Group to be the only solar developer company here at the Nickel Summit 2022. So today, I would like to share our experience, our plan regarding the collaboration of the solar energy in the nickel industry. Okay, before I go deeper to talk about how the solar energy can play an important role in the nickel industry, I would like to start with one of the main issues of the ESG in the nickel industry, which is the carbon footprint. According to the data research by Nickel Institute 2020, 1 kilogram of the nickel metal production is equivalent 13 kilograms of the CO2 emissions. So this number I will consider is a big number in terms of the impact of the nickel metal productions to the environment. And 15% of it, 15% of the total emissions are resulted from electricity consumption. So that number is actually will be our main topic, how we can reduce the 15% of the total emission resulted from the electricity consumption through the implementation of solar energy. So the big question here is actually, can nickel industry help us consider myself as an optimist? I would say no, without no doubt. So, numbers of factors to be considered to produce so-called clean energy. I classify into 4 most urgent focus area, which is one is the waste management, impact and the last but not least is the energy resource and consumption. Really energy intensive, which is right now mostly covered by energy like coal power plants, release a lot of CO2. On the other hand, Indonesian nickel industry is going to move forward to create EV battery production. So consequently, of course, it makes sense that the battery industry will demand or will expect so-called the clean energy which produced with the involvement of green and sustainable energy. Okay, so I start this discussion with talking about sustainability in the nickel industry. So, but I assume some of you even been familiar with SESNA. So let me introduce our company. SESNA is one of the leading local solar developer in Indonesia. Independent power producer, IPP, mining sector, commercial and industrial market. SESNA is established in 2017, we as the first private company in Indonesia has successfully built the first IPP project in Indonesia, which is in Sumba. And then in 2020, we expand our business. We entered into the mining sector, a microgrid project. So our first microgrid project is in Kalimantan for coal mining company. And then we continue to expand our project, and right now together with the nickel industry and IC, we are developing one of the biggest solar projects in Indonesia. So I will say the biggest solar project in Indonesia will serve nickel industry. So here is some of information about our IPP. IPP means here that we develop project, we finance, we install, we operate the project, we produce the quality of right now, Momere Ende, and right now we are here that actually battery is, start to being demand by the market. Here is one of our renewable project, microgrid project. So maybe Pak Muhtazar already mentioned about this project. The project located in Morowali, the mining area belong to the PT Menjaya Mineralindo. So it's a kind of like hybrid project, consists of 400 kilowatt peak solar panel, and also for 250 kilowatt hours battery system combined together with the existing diesel genset. So the system itself allows us to turn off completely the existing diesel genset up to 6 hours. And right now we are in discussion with the client, with the company, to increase the capacity of the solar module and battery. And the goal is actually to turn off the diesel genset completely up to 10 to 12 hours. The scheme is BO with the long-term agreement, means that SESNA take over the project development, finance, construction until the operation and maintenance. The system will produce around 13 million kilowatt hours for over 25 years, and it's equivalent of the CO2 reductions of the almost or more than 10 million kilogram. Okay, so we can go next. So here's also some information about our project pipeline in the commercial and industry market. So we see here that we have a big pipeline around 200 megawatt peak. So that's the one that that I just mentioned. It will be the biggest solar project in Indonesia, because right now I think the biggest capacity in Indonesia is around 20 megawatt hours. So it's jumped from 20 to 200 megawatt peak, and it serves the nickel industry. So the project itself, the configuration itself consists of the solar panel and also the battery energy storage system. The capacity is 200 megawatt peak, and the battery capacity is 20 megawatt hours. The solar PV, the system will produce around 6 billion kilowatt hours for over 25 years. Again, the scheme is BO with the long-term contract period, which is 25 years. So we take over all of it from the project development, finance, construction, until operation and maintenance. And the idea is to reduce the CO2 emissions. So I think it's around 5 billion kilogram. So it's really helped to, build the ESG narrative for the NIC company. So we will have a collaboration with the IMIP, because the IMIP is, we call it like WILUS, so they act as PLN. So there is no PLN in that area, then the IMIP is the grid owner. So we will have a collaboration with IMIP to transmit the produced energy and distribute to the NIC. So the off-taker of the produced energy is the two RKF plant of the NIC, which is the Hengjaya Nickel Industry and the Ranger Nickel Industry. Here is some little information about the technical configuration. So we will have 200 megawatt peak on the ground mounted, and then it will be transmitted through the transmission line around 10 kilometers or 15 kilometers top, and then it will be connected to the IMIP substation, and then from the substation it will be distributed via IMIP's grid line, and then directly injected to the RKF belong to Henjaya Nickel Industry and Ranger Nickel Industry. So yeah, that's maybe it's a really short presentation, but this our closing statement. Actually, building a sustainable future will take time, but there is no better time to act than now. Thank you.
Cheers. Thanks, Rico. Short and sweet. Thank you. Sorry, the screen was off, if you noticed, for a while. Did I hear you correct? 1 to 13 kilograms of nickel to CO2 equivalent? Oh, wow.
So yes, based on the data research from the Nickel Institute 2020.
And I missed some of the numbers there. Your first IPP, that was a big deal. I remember that project. Yeah. What was the size?
Oh, it's a small one. Sumba is small island, right?
Yeah.
It's only 1 megawatt peak.
Oh, okay. Right. Okay. And you're saying the Hengjaya is going to be 200.
Yeah. So actually, there is 2 different projects. One is Hengjaya Mineralindo. It's the mining company.
Right.
So it's a small one, the 400 kilowatt peak with battery, and then we will do the extension. And then the other one, the big one, the 200 megawatt peak, is for the smelter. Hengjaya Nickel Industry and Ranger Nickel Industry. It still belong to the NIC.
NIC, right?
Yeah.
Okay, cool. Yeah, apologies. I couldn't see that.
Yeah.
Is there any questions from the audience? I would be surprised because you're the only solar speaker here today.
Yes, I really appreciate that we are invited here.
It's great. If you hear all the other speeches, it's all ESG, ESG, ESG. And
Yeah.
you're the only one that's here showing. Do we have a question up front here? Can I get the microphone? Why is it really hard?
And then the monitor is turned off.
Hello? Yes, thank you. Okay, my name is Wayan Prenata from PT Ceria. Okay, it's interested, that Ranger Nickel Industry will have solar energy, 200 megawatt. I cannot imagine how wide will be the, what we call the plant, okay, to absorb the solar, okay, the solar. Okay, that's my first question. How wide will be the, what you call, the solar plant? Okay.
Yeah, okay.
And then second, okay, the smelter, okay, the smelter will be operating on 24 hours, okay. And I believe the plant to absorb the heat from the sun will be only on daytime, okay, daytime. How you will supply the power, okay, from the solar if at the night time when the smelters need to run continuous, yeah? Okay, is there any, what you call, power storage, some kind like that? Okay, thank you. That's all my question.
Okay, thank you very much for the question, Pak. So the first question is about the land. So to install 200 megawatt peak, in general, we will need 200 hectares. So 1 megawatt peak is equivalent 1 hectare. Okay, and then second question is a really good question, but so the PV actually, yeah, PV alone without any battery, they will operate it from, in general, 6 a.m. to 6 p.m. So it cannot operate for 24 hours. And we do have here a battery, 20 megawatt hours, but it's small to cover 24 hours because actually the 20 megawatt hours is a system to smooth the intermittency of the solar. Because you know, if there is a cloud coming and then the power will be go up and down. The trick here is actually we working together with the IMIP grid. So we work, the system work together, synchronized with the grid from the IMIP. So for example, IMIP have the coal power plant. So the solar and coal power plant will work together in the same time, synchronized automatically. So it's like, you know, it's like the normal Jakarta PLN. It is not like one power plant will supply all of the Jakarta electricity needs. It consists of many power plants, and then, you know, it's like that.
Clear? Please.
Hi, Arnoud van Hukkelen from ING.
Clearly, I think IMEP has got what, 3.5 gigawatt thermal-fired power capacity, I think, roughly. How big can you realistically make this solar, and what is your limiting capacity? Is that land, or is that a certain percentage of the coal-fired power station that stabilizes the electricity demand?
What are the limitations? Can you talk a little bit about that?
Yeah. So it's also a good question. Actually, what we will do when we develop the project is we see first the load profile. How big is the power that you need every second? That's the first limitation. And then, for example, if you have kind of like, let's say, 10 or 15 megawatt, for example, then it's our top capacity in general. And then we will see the land, which is enough for 15 or 10 or 5. So it doesn't matter. It's really modular, the solar module. Thank you.
But land, I think, is going to be a big limiting factor for some of these bigger ones. We were just talking earlier about 1,000 megawatts. It's 1,000 hectares. You know?
Yeah.
That's a country. That's any other questions? Just a quick one for me. How long is the gestation period from you guys, you know, deciding to go ahead with the project until you turn it over, or you flip the switch and you're turning on? How long is that period?
How long? Sorry, how long the?
From deciding to do a project to turning on the power.
Okay. You mean the construction period?
Yeah.
So I will say if we start from the beginning, from the project development, I think it will take around 2 or 4 months, the project development, and then after we sign the agreement with the client, the construction will be with the big project like 200 megawatt peak, and then we need to build the transmission line.
Right.
So approximately we will need like 12 months.
Okay.
Because you know, we need to build the transmission line.
Sure.
That's the key part.
So, yeah, because you're bringing in the panels already prefab, you're just putting them together.
In general, for the installation of the solar system, it takes only like 6 to 8 months, I would say.
Right. Yeah, so the transmission is the...
Transmission is the issue.
Okay. Actually, we have a question here.
Thank you, Pak Syah Alam, for the presentation. My name is Marcel from Harum Energy. May I know what is the capital expenditure for each megawatt to build the solar panel? And the second question is, how much is the electricity cost generated from the solar panel, and how it's compared to the coal-fired power plant? Thank you.
Okay, so I forgot to mention about the cost. So actually, for example, if we see for the project in the mining area, which is they use the diesel genset, and then we install solar with the kind of like big battery compared to the installed solar module. So I will say that the cost of the electricity from the solar is 20 to 30% less than the electricity from diesel genset. That's the first. And then if we go to like big project, then the kind of like the competitor is not diesel genset, of course, is the power from the grid, which is mostly covered by coal power plant. So I will say, if we compare, we can do like 10 to 15% below the existing LCOE or the cost of the electricity generations. And then the first question is actually, oh yeah, the capex, yeah. If we think only about the solar system with no battery, so the capex will be around 60 cents to 70 cents per watt peak. So 1 megawatt is around 600,000 to 700,000. This excluded the battery and also, you know, the land and also the permit and license. And transmission, yeah, it's good. Thank you, thank you.
And is that, no, that you said that was based on diesel. I'm assuming that was, say, last year's price, whereas today we're above 21,000
Yeah,
per liter.
yeah.
So you're going to actually be far more competitive.
Yeah,
right?
yeah. When we do our own calculations, so actually the project in Hengjaya Mineralindo, they can save around like up to 40%.
Yeah.
Yeah, 40%.
Yeah, well, when we were looking at Kideko, I remember it was...
Sorry, Hengjaya, or Kideko,
yeah,
same
but
thing.
Kideko, it
Yeah.
was, the price of fuel was like 12,000 rupees.
Yeah. It's,
So, well, hey, thanks, Rico.
Thanks,
great
man.
presentation, and thanks for coming up and showing everybody what ESG is about.
would love to do it. Thank
Great.
you.
Thank you.
Bye-bye.